Bismillahirrahmanirrahim. Assalamu alaikum dear students. Welcome back. Students, let's start the video and point out the different other mistakes, okay? Student, basically if you are a site engineer and you are working for a such project or you are inspecting, let's say, slabs like this. So you see in this slab basically one major mistake you see here that they provide bend to these electrical pipes, okay? So basically the first thing, you will never allow such kind of bend at the middle portion. Clear? One thing you should keep in mind. Clear? The other thing is, which is very important, is that you see the lapping in the mid zone, which I already mentioned you in lecture number 2, that you will never allow such kind of lapping. Clear? The other thing is that you see the one bar is, you can see, which is at the bottom, while the other bar is at the top. Okay. So what does it mean? If let I assume that in this direction basically the bars are basically in the main bars. Okay. So if they are the main bars, let's say, so all the bars should be provided in bottom, okay, and all the bars should be in this direction basically. You can say in this direction it should be at the top. Clear? So this is another mistake. You see this bar, which is bottom bar, while this you can see it is on the top. Although both the bars are running in same direction. So this is also a mistake. You never allow. You see this bend over here. Okay, this should never be allowed. Okay, you see the lap over here. This should never be allowed. Okay, and one important thing which when I was working on site, basically, you never allow such kind of conduits in your structure system. Why? Because it creates a very weak section. For example, you see this pipe which is just over here. Sometimes they use larger size pipes. Clear? So the thickness of the slab, if you do a slab designing, for example, so we basically use a specific thickness of the slab. Clear? That is around about 6 inches. Clear? No, this is 6 inches. While you see, if you are providing a 1-inch pipe over here, they create basically, or you can say it give you a thickness of 5 inch at this section. Okay, at this section. Now it decreases your thickness of the slab up to, you can say, 1 inch. Okay. Now that it basically create a weaker section, and there will be a chances of the slab to crack at this line. Clear? Similarly at this line. Sometimes they use so many pipes. So you should never allow such kind of conduit system. Then must, for example, if you see here this, okay, a junction at the basically these things matters in mega structure. Clear? The best way for such kind of arrangement is that you need to provide this kind of type system on the bottom surface of the slab, and then provide basically sealing, okay, to, you can say, to hidden such kind of pipes. Okay, so that is a good practice. We should never allow such kind of conduit system. Okay, because they create weaker section in some place. Clear? The other thing which I see over here, there will be no chairs is provided to the reinforcement, or you can say those you can say for concrete cover. Okay, because in steel basically when we are designing a concrete slab, so we provide a clear cover to the bottom reinforcement around about 3 by 4 inches. Clear? Now we must need to ensure such clear spacing, and here you see that they don't provide those chairs or stones or okay to maintain this flat surface. And that is also one kind of mistake which I see in this video or in this flat system. And similarly, sometimes basically they can maintain such kind of spacing by just when they start concreting, they're lifting this mesh and they provide such kind of arrangement. So if you are working with such people, they told you that we will provide that 3 by 4 inches cover during work. How they provide it? They're lifting the mesh and they maintain their spacing. I think that is a wrong practice. You should need to provide in before completing those chairs which will be kept below the bottom bar, and its size must be equal to 3 by 4 inch or 1/2 inches, whatever the design the structural engineers will provide it. Okay. One thing what you must keep in mind that this is the responsibility. These are all the responsibilities of a structural engineer that he mentioned: the lapping zone, okay, all other weaker zones. Okay, so this is the responsibility of a structural engineer. Let us watch the rest of the part of the video, okay, and see what different mistakes are.
From civil engineers, and today it has been done in this RCC slab, but now they are not able to fix those mistakes which I am telling you in this video. Let's start, guys. This is RCC slab from each other. The main but the dia is same, which is 12 millimeter. Distribution bar and main bar dia is.
I comment on this part in my lecture number 1. Please watch lecture number 1 whether it is correct or not correct. Whether it should necessary that both the bar dia should be same or not same. So please watch lecture number
12 millimeter here, right? Now you can see there are some other mistakes which I have to point out.
One thing you see here, that they provide such kind of bends over here, and these bends should never be allowed. Okay, should never be allowed. Now you see the bar is bent over here. Okay, if someone for example comment that it's near the support, we bend the bar and they go over the support and then it bend again. Okay, now you see this bend over here and going and then bend. Now it's not pass over the support, right? There is no support. So why you are bending the bar? They just bend the bar due to these pipes. And you see there are two pipes which are running basically at the same location. And basically what I told you in the initial part of this picture, that we don't allow such pipe arrangement. If they are using, so they must separate them. Okay, but we upset such kind of practice. Okay, and one thing is which I see in this video is that basically, let us watch the video.
You can see there are some other mistakes which I have to point out. We have discussed in more videos about lapping length, that the lapping length should be provided at the
I already mentioned you, okay, and I basically
met for slab, for beam and column, but here you can see this is support means this is column, right? This is RCC column for this slab and this is beam, right? Top beam, but this you can see this is lapping length, but I've already discussed in supports. Okay, this is end of the support, so this is a big mistake. You should not provide lapping length at the end of the support like this, so it's support, but lapping length should be met. But now here it's wrong, right? Here is the other mistake. Already lapping length, we have already discussed that the lapping length should be not provided at the same point. Two mistakes are present here, you can see in this. Now you can see this is lapping length. Okay, so it's lapping length, but lapping length is provided at the same point, so it should be not provided at.
I already comment in lecture 3 basically, that is part 3 how we staggered basically the so please watch that video, that is alternating lapping and staggering the lapping. Okay, so
the same point. Okay, so
watch that video,
okay, because it can make
how we can do it.
I have to discuss. You can see this is farm work, wood farm work, right?
Yes, we can appreciate this. We don't allow such kind of cracks basically in farm work, or you can say hollow areas in farm work, because it causes bleeding and something a very bad surface finishing of the lower portion of the concrete. So we must need to provide some kind of plastics or some kind of arrangement.
Work, wood farm work, right? To giant the open. If bleeding, so it's a day, all the farm work is open. But now they are not able to fix these because the RCC, you can see the farm work. So farm work mistake, lapping length mistake, right? But here you can see some other mistakes here about its spacing. You can see the spacing is a difference, right? Here this is about 4 inches. You can see this is 5 inches.
It looks like basically, I think so, there is not greater differences basically in the spacing. You see here spacing between these, let me show you, spacing, this spacing and this spacing, although half inch or something, it will be acceptable, not it is a very great difference almost, but the code you should need to understand what code format permit you. Okay, so I think so this is, there is not
Right, spacing problems,
so
lapping length problem, right?
Okay,
But here is the other mistake. You can see here stirrups, which dia is 6 millimeter. This is RCC beam.
how you can say that the stirrup dia is 6
Top beam,
yes,
and total
yes,
numbers
6
of steel bars are used here.
number 3.
7 numbers of steel bars, 3 at this side and 3 on this side. One is at the mid, and each steel dia is 16 millimeters, so it's okay. But if you come to its stirrup spacing is wrong. That's why, because it's here 7 inches, but it's about 8 inches. But we have already discussed at the end of the support, the stirrup should be closely. We have already discussed, but it's not closely. It's same distance.
There he make a mistake. Clear? What is the mistake? Already he is correct that at the support basically the stirrups are closed, while at the middle portion the stirrup distance is you can say is increased. But it is not correct. It totally depends upon the shear strength. Okay, it totally depends upon the structural design of the beam. Okay. Now if I want to show you some other for example some other codes, what code says basically. So let me show you, for example, this is ACI code. Clear? So in ACI code basically you see here which is for beam. Okay, determine a transverse information shall be in accordance with the restriction. Okay, here if required shear reinforcement shall be provided using stirrup roots or longitudinal bent up bars. Okay, maximum spacing of shear reinforcement shall be in accordance with the table of this. Now you see, when we calculate the shear reinforcement spacing basically structure design, concrete structure design, if for example our spacing basically increases from these specified spacing, that is d by 2 or d by 4. d by 4 is used when our nominal shear strength basically increases from 4 times our OC prime under root BWD, okay, and in that case we have to use D by 4. While if nominal shear reinforcement is lesser than this value, we have to use D by 2. Now the question is that if our shear reinforcement spacing, let's say, increases from these limits, okay, so then we provide these spacing at basically in those areas basically where we have to where that shear exists basically. Now sometimes basically we design the beam that, for example, all the spacing of the shear reinforcement increases from this value. Let's say this is 24 inches, which is more than 24 inches. Almost it should be kept in mind that we never allow shear reinforcement more than 9 inches. Okay, 9 inches basically that is a limit, which is I think so. This is an ACI code limitation. We never allowed. Okay, but the limitation is that 12 inches. I think so. 12 inches for D by 4. Okay, 3 by 4. We need not to allow spacing more than 12 inches. Okay. Now, if sometimes spacing comes out to be more than 12 inches, we say that provide 12 inches spacing through the beam section. So in that case, basically this the person who are saying that uniform spacing basically non-uniform spacing basically needs, so the person is wrong. That's basically this. We need to provide basically a uniform spacing in that case. Okay, we say provide 12 inches. Okay, 12 inches center to center spacing to all stirrups. So in that case, we got a uniform spacing. But although sometime if I show you a diagram, let me show you this diagram here. You see the shear diagram. The shear is maximum at the support, okay, and minimum at the central portion. Now 13.6 basically is what it is the amount of shear. Now if we determine the spacing for these internal portion or middle portion, and its spacing comes out to be less than basically the minimum spacing, okay, or let's say we determine the spacing for this 13.6 tip shear, and the spacing comes out to be lesser than the minimum spacing, because for shear reinforcement we have certain limitations. Okay, we have certain limitations. The spacing should not be more than the maximum spacing, like the one which I show you in ACI code. These are the limitations, 12 inches. For example, you calculate the spacing, and in this case for 13.6, okay, for 13.6 tip shear, and the spacing comes out to be 15 inches center to center. Now we can't use 15 inches center to center. Okay, we can't use 15 if this condition exists. If this condition exists, we have 24 inches. Let's say for 13.6 inches kip, we calculate the stirrup spacing, and it comes out to be 30 inches center to center. We are code not allowed us, okay, if this condition exists, the code do not allow us to increase the spacing more than 24 inches or equal to. Now you have to select the lesser value of these two. Now let's say I divide D by 2, that gives me 18 inches or 15 inches. So what I did basically, I say I provide stirrups at 15 inches center to center through the beam. So in that case we got a uniform spacing. Okay, it is not necessary that you have to use minimum spacing near the support and larger spacing at the mid portion. So I think, but when we are dealing with SMRF structure like the one you see here, in SMRF, that is special movement resisting frame. If somebody working on SMRF structure, which is basically constructed in highly earthquake regions. So in that case, you see the spacing. Okay, this should be maintained. You see, at a distance for 2 times of h, you have to use these spacing. Okay, this is very lower minimum values, almost 4 inch, 3 inch. Okay, but after beyond that point, you see we increase the distance up to d by 2. We never increase the spacing more than d by 2. Clear? So in that case, basically, the recorder is right. We have to use basically different spacing. But some structural engineer may basically encouraging that continue this spacing through the span of the link. So in that case, we basically what we got the uniform spacing. So this is all the provisions basically which we made, and this is not necessary that you have to use basically uniform spacing. So this is all about shear reinforcement. Okay. See you in next lecture. Basically in that part we find out other mistakes, and I think so there is other, I see there are